All right, this is chi-squared goodness of fit scenario number 3. In a recent year at the 6 p.m., and this is page 219, I'm sorry. In a recent year at the 6 p.m. Time slot, televisions 2, 3, 4, and 5 captured the entire audience. In other words, 4 channels. Everyone was either, if they're watching TV, they were watching one of these 4 channels at 6 p.m. And they had 30%, 25%, 20%, and 25% respectively. So I'm going to go ahead and label those down here just to help me out for organization purposes. So this had 30%, this has had 25%, this is 20%, and this is 25%. All right. So in some previous year, that's what they had. During the first week of the next season or session, 500 viewers are interviewed. I should say that they're randomly, but it doesn't. And the table records the observations. Did the viewing preferences have a statistically significant change? Well, when I look at this, I have 1, 2, 3, 4. I have multiple categories. And as soon as I have multiple categories, I'm going, this is going to be a chi-square. And they're asking me, really, did it change or did it match what was previous? And since they're asking me whether it changed or matched what previous, this lets me know I'm probably working with a chi-square goodness of fit test. And so basically we want to know whether or not what we are seeing today matches what it was in the past. And as always, I really recommend doing a total. This has actually been totaled out for us, so we don't have to this time, but if we summed them all up, we'd say 500, and that's what they said they had done. So we're going to go ahead and write our null hypothesis, and our null hypothesis is television or TV viewership matches or is the same, matches the historical or matches the previous, but I'm going to go with historical year. All right, so it matches the historical distribution or historical years distribution. I'll probably just make it a historical distribution. That would make it faster. And the alternative is TV viewership does not match the historical distribution or the previous. So notice that we're matching or we're not matching. It stayed the same or it changed. All right. Please note, this is always going to be based on equals. So if you'd done it as change, it'd be TV viewership is the same as it was previously, or TV viewership changed. All right. TV viewership is the same for the null. TV viewership changed. Because the null hypothesis is always going to be based on some sort of equal. In other words, it didn't. It's going to be that it was the same. All right, so our conditions. The first condition is random sample. And as I noted earlier, they didn't tell us it was. Random sample is not given. We assume the sample is representative of the entire population. In other words, we sure hope it was. Otherwise, this is worthless data. All right. Two, we need to worry about our expected values. And remember, expected values must be greater than 5. They didn't give them to us. So remember, expected values, expected equals essentially n times p. Well, in this case, n is 500. So 500 times p. So this is going to be 500 times 0.30. So we have an expected value of 150. Here we have 500 times 0.25. So we have an expected value of 125. 500 times 0.20. We have an expected value of 100. 500 times 0.25. And we have an expected value of 125. And this sums to 500. All right. So all of our expected values, they happen to be whole numbers, but expected values could be decimals. The main thing is they need to be greater than or equal to 5. Expected values are all greater than 5. See the table. The third thing is our observed data must be whole numbers. Observed data are counted / whole numbers. And they are. All right, so we've done that. We're going to write our formula, and our formula is basically chi-squared equals observed minus expected squared over the expected. Our degrees of freedom is categories -1, cat -1. And our categories, we have 1, 2, 3, 4 categories. So this is going to be 4 minus 1, which equals 3. So our categories happen to be 3. All right, so we're going to start plugging into our formula. And I'm going to go ahead and rewrite it, even though I don't need to, equals observed minus expected squared over expected. And my observed for the first category was 139. So we're going to have 139 minus 150. And I got to make sure I come back, make sure I square that. If you don't show that, you're going to lose points. So don't do that. Please make sure you have it listed. And we're going to do the lowest and the highest. So in this case, 111 minus 125, because this is what that is. And we're going to square that, and we're going to divide that by 125. All right, now I'm going to go ahead and take a moment and put up that information in the calculator because I don't have it there now. Stat edit, I need to clear this out. And we have an observed of 139, a 138, a 112, a 111. So there's my observed values. My expected values were 150, 125, 100, and 125. All right, so I have it in. I'm going to run the test, stat test chi-squared GOF, goodness of fit, L1, L2, degrees of freedom, 4 minus 1 to 3 degrees of freedom. And we end up getting a chi-squared value equals 5.167, and our p-value is 0.159. Let's assume an alpha of 0.05. This is greater than. So we're going to fail to reject the null. Also going to take a moment while we're here, and I'm going to write down my contributions. My first contribution is 0.806. The next one is 1.352. Then I have 1.44 and 1.568. And this is for channel 2, this is channel 3, this is channel 4, and this is channel 5. Now, please remember where this came from. This value, the 139 minus the 150 squared divided by 150 gives me 0.806. So here, we'll check it out real quickly, just as a reminder. 139 minus the 150. I'm going to go ahead and square that value and divide by 150. And sure enough, I get 0.806. So this was the first part of it, then the second one, then the third one, and this is my last one. Obviously, this was the largest value. All right, this had the greatest change. So this is the biggest change. And it had the biggest change overall. Unless when I look at it, it's like, okay, this one had the biggest change. And I know it was the biggest change based on the contribution. So it had the biggest change. And I can look at these and tell whether they had a positive change or a negative change. So I expected 125 and I got 111. So this had a negative change and it happened to be the biggest. This was what I expected it to be 100 is 112. So it had a positive change. 125 to 138, this had a positive change. And this one, I expected 150 and I got 139. So I had a negative change. All right. So of my positives, third and fourth one, they're pretty close, but number 4 had the largest positive. So number 4 had the largest positive. Number 5 had the biggest change overall, and it happened to be negative. Okay. And not that they ever ask you to break that down. So our conclusion. Our p-value is 0.159. We fail to reject the null. There is not sufficient. There's not enough evidence. There may be some evidence, but there's not enough to say that TV viewership changed. All right, or that the distribution of TV viewership changed. All right. So we can't say that TV viewership changed. All right, and that will take care of this video. I hope that helps. And that'll end this one.